Hello everyone, and welcome to my channel. Here, we explore the fascinating world of science, from the mysteries of the universe to the wonders of everyday life. Sit back, relax, and let's discover something amazing together. Today, I would like to invite you on a journey into one of the most powerful and mysterious systems on our planet, the ocean. Covering more than 70% of the Earth's surface, the ocean is the largest living environment on Earth, yet it remains one of the least explored. Beneath its surface lies a world of extreme depths, extraordinary life forms, and complex processes that shape the climate and sustain life as we know it. Although humans depend on the ocean for oxygen, food, climate regulation, and economic activity, much of its importance is often overlooked. Many people see the ocean simply as a vast body of water, without realizing how deeply it influences our daily lives and the future of our planet. In this presentation, I will explore 7 key aspects of the ocean. We will begin by examining its immense scale and hidden structure. Then move on to the remarkable biological abilities of marine life and the unique ecosystems that support global productivity. We will also discuss the ocean's critical role in regulating Earth's climate, as well as the serious threats it faces today. Through this journey, the goal is not only to share scientific knowledge, but also to deepen our appreciation of the ocean and highlight why protecting it is essential for the future of humanity. Chapter 1. Introduction. The vast and mysterious world of the ocean. The ocean is the largest living environment on Earth. A vast and dynamic system that shapes the planet in ways both visible and hidden, covering more than 70% of the Earth's surface. The ocean dominates the planet's appearance from space, wrapping the globe in deep shades of blue. Yet despite its immense presence, the ocean remains one of the least understood realms of our world. Much of what lies beneath the waves is still unknown, unexplored, and unmapped, making the ocean both familiar and mysterious at the same time. For centuries, humans have relied on the ocean for food, transportation, trade, and inspiration. Ancient civilizations grew along coastlines, using the sea as a source of nourishment and a pathway to new lands. Sailors once feared the open ocean, believing it to be filled with sea monsters and endless abysses. Today, while modern technology has replaced superstition with science, the ocean continues to challenge our understanding. Advanced submarines, satellites, and deep-sea probes have revealed astonishing discoveries. Yet they have also shown how much remains beyond our reach. The purpose of this presentation is to help the audience gain a deeper understanding of the ocean, not only as a body of water, but as a complex and powerful system essential to life on Earth. By exploring scientific facts, surprising biological phenomena, and the ocean's role in regulating climate, this presentation aims to reveal why the ocean is far more than a distant, silent expanse. It is an active force that influences weather patterns, supports countless life forms, and sustains human existence in ways many people rarely consider. One of the most striking facts about the ocean is its sheer scale. While land environments are where human activity is most visible, they represent only a small fraction of the planet's living space. In terms of volume, the ocean provides the largest habitat on Earth, supporting an extraordinary range of organisms, from microscopic plankton to the largest animals ever to exist, such as blue whales. Despite this, scientific exploration of the ocean lags far behind that of land or even outer space. Humans have mapped the surface of Mars in greater detail than the ocean floor, a reality that highlights how challenging and expensive deep-sea research can be. This sense of mystery is part of what makes the ocean so fascinating. Darkness, extreme pressure, and freezing temperatures dominate the deep sea, creating conditions that are hostile to human life but surprisingly suitable for many specialized organisms. Each expedition into the depths has the potential to reveal new species, unfamiliar ecosystems, and unexpected forms of life. These discoveries often challenge long-held assumptions about what life needs to survive, forcing scientists to rethink basic biological principles. Beyond its biological importance, the ocean plays a crucial role in shaping Earth's climate. It acts as a massive heat reservoir, absorbing energy from the sun and redistributing it around the globe through ocean currents. Without this process, many regions would experience far more extreme temperatures, making the planet less hospitable for life. The ocean also interacts constantly with the atmosphere, influencing rainfall patterns, storm formation, and long-term climate trends. Understanding the ocean is therefore essential for understanding climate change and its potential impacts on human societies. Another key objective of this presentation is to highlight the surprising and sometimes astonishing facts that make the ocean a subject of endless scientific curiosity. From creatures that can regenerate lost body parts to organisms that glow in complete darkness. Marine life displays a level of diversity and adaptability that is difficult to match on land. These phenomena are not only fascinating but also valuable to science, as they inspire medical research, technological innovation, and new approaches to sustainability. At the same time, this presentation seeks to emphasize the importance of protecting the ocean. Human activities, such as pollution, overfishing, and carbon emissions, are placing increasing pressure on marine ecosystems. Problems like ocean acidification and plastic pollution are no longer distant threats. They are measurable, global issues with long-term consequences. By understanding how the ocean functions and why it matters, individuals and communities can make more informed choices that contribute to its preservation. In conclusion, the ocean is not merely a backdrop to life on Earth. It is a central player in the planet's biological, chemical, and physical systems. Its vastness inspires awe. Its mysteries invite exploration, and its influence touches every living organism, including humans. This presentation begins a journey into that immense blue world, uncovering the hidden structures, remarkable life forms, and essential processes that make the ocean one of the most important and fascinating subjects of scientific study. Through knowledge and awareness, we take the first step toward appreciating and protecting the ocean that sustains us all. Chapter 2. The immense scale and structure of the ocean. To truly understand the ocean, you must first grasp its immense scale and complex structure. While the surface of the ocean is familiar to most people, waves breaking along shorelines, ships crossing open waters, the true magnitude of the ocean lies beneath the surface. In terms of volume, the ocean is the largest living environment on Earth, containing approximately 97% of all the planet's water. This vast body of water creates a three-dimensional habitat unlike any environment on land, extending thousands of meters downward into darkness. One of the most striking features of the ocean's scale is its depth. The average depth of the ocean is about 3,700 meters. Yet this number alone does not fully capture the extremes that exist beneath the waves. The deepest known point on Earth, the Mariana Trench in the western Pacific Ocean, reaches a depth of nearly 11,000 meters. To put this into perspective, if Mount Everest were placed inside the trench, its peak would still remain more than 2 kilometers below the ocean's surface. At such depths, pressure is more than 1,000 times greater than at sea level, creating conditions that would instantly crush most human-made objects. The ocean is not a flat, featureless basin. Instead, the seafloor is shaped by dramatic geological structures that rival, and often surpass, those found on land. Running through the center of many oceans is the Mid-Ocean Ridge System, a continuous chain of underwater mountains stretching over 60,000 kilometers. This makes it the longest mountain range in the world, even longer than all continental mountain ranges combined. These ridges are formed by tectonic plates slowly pulling apart, allowing molten rock from beneath the Earth's crust to rise and solidify, constantly creating new seafloor. In contrast to these towering underwater mountains, vast flat regions known as abyssal plains cover large portions of the deep ocean floor. These plains lie at depths of 4,000 to 6,000 meters and are among the flattest and smoothest areas on Earth. For a long time, scientists believed abyssal plains were lifeless deserts. However, research has revealed that they host a surprising diversity of organisms, many of which are specially adapted to survive in extreme darkness, cold temperatures, and high pressure. These discoveries have transformed our understanding of where life can exist. Another important structural feature of the ocean is the continental shelf. This gently sloping area extends outward from continents before dropping steeply into the deep ocean. Although continental shelves make up a relatively small portion of the ocean's total area, they are among the most biologically productive regions on the planet. Shallow waters allow sunlight to penetrate, supporting the growth of algae and phytoplankton, which form the foundation of marine food webs. As a result, Many of the world's major fisheries are located along continental shelves. Despite centuries of exploration, much of the ocean remains unexplored. Scientists estimate that more than 80% of the ocean has not yet been fully mapped or studied. This lack of knowledge is not due to a lack of interest, but rather to the immense technical challenges involved. Extreme pressure, total darkness, and vast distances make deep-sea exploration expensive and dangerous. Even with modern technology such as autonomous underwater vehicles and deep-sea submersibles, exploration progresses slowly. This reality has led scientists to describe the ocean as Earth's final frontier. Unlike outer space, which captures public imagination through rockets and astronauts, the ocean hides its secrets silently beneath the surface. Every deep-sea mission has the potential to discover new species, unknown geological formations, or unexpected chemical processes. In recent decades, researchers have found ecosystems around hydrothermal vents, underwater volcanoes, and deep trenches, places once thought incapable of supporting life. Understanding the structure of the ocean is essential not only for scientific knowledge but also for practical reasons. Seafloor mapping plays a crucial role in navigation, undersea cable installation, earthquake prediction, and resource management. The internet itself depends heavily on fiber optic cables laid across the ocean floor, following routes carefully planned using detailed maps of underwater terrain. In this way, the hidden structure of the ocean directly supports modern global communication. In summary, the ocean's scale and structure reveal a world far more complex and dynamic than its calm surface suggests. From towering underwater mountain ranges to vast abyssal plains and record-breaking trenches, the ocean floor is shaped by powerful geological forces that continue to reshape the planet. At the same time, the fact that most of this environment remains unexplored reminds us of how limited our knowledge still is. By studying the immense size and intricate structure of the ocean, we take an important step toward understanding the planet we call home, and recognizing how much there is still left to discover. Chapter 3. Extraordinary biological abilities of marine life. The ocean is home to some of the most extraordinary forms of life on Earth. Unlike terrestrial environments, where conditions are relatively stable and familiar to humans, marine environments range from sunlit coastal waters to pitch-black depths under extreme pressure. To survive in such varied and often hostile conditions, marine organisms have evolved remarkable biological abilities that challenge conventional ideas about life. These adaptations not only demonstrate the power of evolution, but also reveal how flexible and resilient life can be. One of the most fascinating examples of biological adaptation in the ocean is found in certain species of jellyfish. The so-called immortal jellyfish, Turritopsis dohrnii, possesses the unique ability to reverse its life cycle. Under stress or injury, this jellyfish can transform its adult cells back into an immature state, essentially starting its life over again. While this does not make the jellyfish truly immortal in practice, it represents a rare form of biological rejuvenation that has captured the attention of scientists studying aging and cellular regeneration. Another astonishing ability observed in marine life is the capacity for sex change. Several species of fish, including clownfish and wrasses, can change their sex in response to social or environmental conditions. In clownfish communities, for example, a strict social hierarchy exists. If the dominant female dies, the largest male will transform into a female, ensuring the continuation of the group. This ability challenges the traditional understanding of fixed biological sex and highlights the adaptability of marine species to maintain reproductive success. Regeneration is another area where marine organisms demonstrate extraordinary capabilities. Starfish are perhaps the most well-known example. Some species can regenerate entire bodies from a single arm, provided that part of the central disc remains intact. This process involves complex cellular coordination and has made starfish an important subject in regenerative biology research. Other marine organisms, such as sea cucumbers, can expel internal organs as a defense mechanism and later regenerate them, a strategy that appears extreme but proves highly effective for survival. In the deep ocean, where sunlight does not reach, many organisms have developed the ability to produce their own light through a process known as bioluminescence. This phenomenon is caused by chemical reactions within the organism's body, producing light without heat. Bioluminescence serves multiple purposes: attracting prey, confusing predators, and facilitating communication between members of the same species. The soft glow of bioluminescent creatures illuminates the darkness of the deep sea, creating one of the most visually striking yet least understood ecosystems on the planet. Marine animals have also evolved highly specialized sensory systems. Sharks, for instance, possess an extraordinary ability to detect electrical signals. Using specialized organs called ampullae of Lorenzini, sharks can sense the weak electrical fields produced by the muscle movements of other animals. This allows them to locate prey even when visibility is extremely low or when prey is hidden beneath sand. Such sensitivity gives sharks a significant advantage as predators and demonstrates how evolution can shape senses beyond human perception. Communication in the ocean presents unique challenges due to limited visibility, especially in deep or murky waters. As a result, many marine mammals rely on sound rather than sight. Whales and dolphins are known for their complex vocalizations, which they use for navigation, social interaction, and hunting. Dolphins use echolocation, emitting sound waves that bounce off objects and return as echoes, allowing them to see their surroundings through sound. Some whale songs can travel hundreds of kilometers across the ocean, making them among the longest distance communication signals used by any animals on Earth. Marine life also exhibits remarkable tolerance to extreme environmental conditions. Organisms living near hydrothermal vents, for example, thrive in environments with toxic chemicals, complete darkness, and temperatures that can exceed 300 degrees Celsius near vent openings. These organisms rely not on sunlight but on chemosynthesis, a process in which bacteria convert chemical energy into organic matter. This discovery fundamentally changed scientific understanding of how ecosystems can function, proving that life does not depend solely on sunlight. These extraordinary biological abilities are not just scientific curiosities, they have practical implications for human society. Research on marine regeneration has influenced medical studies on tissue repair and wound healing. Bioluminescent proteins are used in genetic research and medical diagnostics. Even shark sensory systems inspire new technologies for underwater detection and navigation. In this way, the ocean serves as a living laboratory, offering solutions to problems humans have yet to solve. In conclusion, the ocean is a realm of biological innovation, where life has evolved in ways that often defy human expectations. From organisms that can reverse aging to animals that communicate across vast distances, marine life showcases the limitless possibilities of adaptation. These extraordinary abilities remind us that much of the ocean's biodiversity remains unexplored and poorly understood. As scientific research continues, the ocean will undoubtedly reveal even more remarkable examples of life's resilience and creativity, reinforcing the importance of studying and protecting this extraordinary environment. Chapter 4. Unique ecosystems and ocean productivity. The ocean is not a single, uniform environment but a collection of highly diverse ecosystems, each shaped by specific physical, chemical, and biological conditions. From sunlit surface waters to the darkest depths of the seafloor, these ecosystems support life in ways that are both unexpected and highly efficient. Some marine ecosystems function without sunlight, while others drive the productivity of the entire planet. Understanding these systems reveals how the ocean sustains life on Earth at both local and global scales. One of the most remarkable ocean ecosystems is found around hydrothermal vents. These vents occur in regions where tectonic plates move apart or collide, allowing seawater to seep into the Earth's crust, heat up, and then erupt back into the ocean loaded with minerals. The water released from hydrothermal vents can reach extremely high temperatures, yet life thrives around them. Unlike most ecosystems on Earth, vent communities do not rely on sunlight. Instead, they are powered by chemosynthesis, a process in which bacteria use chemical energy, such as hydrogen sulfide, to produce organic matter. These bacteria form the base of a food web that includes giant tube worms, clams, and specialized crustaceans. The discovery of hydrothermal vent ecosystems in the late 20th century fundamentally changed scientific understanding of life on Earth. Before this discovery, It was widely believed that sunlight was essential for all ecosystems. Vent communities proved that life could exist in complete darkness, relying solely on chemical energy. This finding has had implications beyond oceanography, influencing the search for life on other planets and moons where sunlight may be absent but chemical energy is available. Another important deep-sea ecosystem is found on the abyssal plains, once thought to be barren and lifeless. These vast flat regions of the seafloor are now known to host a variety of organisms adapted to extreme pressure, low temperatures, and limited food supply. Many abyssal species grow slowly and live for exceptionally long periods, reflecting the stable yet resource-poor nature of their environment. While productivity is low compared to shallow waters, the sheer size of abyssal plains means they play a significant role in global ecological processes, including carbon storage. Closer to the surface, ocean productivity increases dramatically. One of the most critical components of marine productivity is phytoplankton, microscopic, photosynthetic organisms that float in the upper layers of the ocean. Despite their small size, phytoplankton are responsible for producing more than half of the Earth's oxygen. Through photosynthesis, they convert carbon dioxide and sunlight into organic matter, forming the foundation of most marine food webs. Without phytoplankton, marine ecosystems would collapse, and the planet's atmosphere would be profoundly different. Phytoplankton also play a central role in the global carbon cycle. When these organisms absorb carbon dioxide during photosynthesis, they help regulate atmospheric carbon levels. When they die, some sink to the ocean floor, transporting carbon into deep-sea sediments in a process known as the biological carbon pump. This mechanism allows the ocean to store vast amounts of carbon for long periods, reducing the concentration of greenhouse gases in the atmosphere. Coral reefs represent another highly productive and biologically rich marine ecosystem. Often referred to as the rainforests of the sea, coral reefs occupy less than 1% of the ocean floor yet support approximately 25% of all marine species. Corals themselves are animals that live in symbiosis with photosynthetic algae called zooxanthellae. This relationship allows reefs to thrive in nutrient-poor waters by efficiently recycling energy and nutrients. In addition to their ecological importance, coral reefs provide coastal protection, support fisheries, and contribute significantly to tourism economies. The productivity of ocean ecosystems is not evenly distributed. Coastal upwelling regions, where deep, nutrient-rich water rises to the surface, are among the most productive areas in the ocean. These regions support large populations of fish, seabirds, and marine mammals. Many of the world's most important fishing grounds are located in upwelling zones, highlighting the direct link between oceanographic processes and human food security. Marine ecosystems also exist in extreme and unexpected environments, such as polar seas. Despite freezing temperatures and seasonal darkness, polar oceans support highly productive ecosystems during certain times of the year. Seasonal blooms of phytoplankton fuel complex food webs that include krill, fish, seals, and whales. These ecosystems are particularly sensitive to climate change, as small changes in temperature or ice cover can have cascading effects throughout the food web. In conclusion, the ocean's ecosystems are diverse, interconnected, and essential to life on Earth. From hydrothermal vents that operate without sunlight to phytoplankton that generate much of the planet's oxygen, marine systems demonstrate extraordinary efficiency and adaptability. Ocean productivity supports global food webs, regulates the climate, and sustains human societies. Recognizing the importance of these ecosystems is a crucial step toward protecting the ocean and ensuring its ability to support life for generations to come. Chapter 5. The role of the ocean in climate and Earth systems. The ocean is one of the most powerful regulators of Earth's climate and environmental systems. Although it often appears calm and unchanging, the ocean is constantly in motion, exchanging heat, gases, and energy with the atmosphere and the land. Through these processes, the ocean plays a central role in shaping global climate patterns, influencing weather, and maintaining conditions that make life on Earth possible. One of the ocean's most important climate functions is its ability to regulate global temperature. Water has a high heat capacity, meaning it can absorb and store large amounts of heat without experiencing rapid temperature changes. The ocean absorbs most of the excess heat generated by solar radiation and human-induced climate warming. By doing so, it prevents extreme temperature fluctuations and helps stabilize the planet's climate. Without the ocean's buffering effect, daily and seasonal temperature differences on Earth would be far more severe. Ocean currents are another critical component of the climate system. The global ocean circulation, often referred to as the ocean conveyor belt, transports heat, nutrients, and dissolved gases around the world. Warm surface currents, such as the Gulf Stream, carry heat from the tropics toward higher latitudes, warming coastal regions and influencing regional climates. In contrast, cold deep water currents move toward the equator, redistributing colder water and maintaining balance within the system. This circulation helps explain why regions at similar latitudes can have very different climates. The ocean also plays a vital role in the global carbon cycle. Human activities, particularly the burning of fossil fuels, release large amounts of carbon dioxide into the atmosphere. The ocean absorbs approximately 30% of this carbon dioxide, acting as a major carbon sink. This absorption helps slow the rate of climate change by reducing the concentration of greenhouse gases in the atmosphere. However, it also leads to chemical changes in seawater, a process known as ocean acidification, which has significant consequences for marine life. In addition to absorbing carbon dioxide, the ocean stores vast amounts of carbon in its depths. Through biological and physical processes, carbon is transported from the surface to deep waters and sediments, where it can remain for hundreds or even thousands of years. The amount of carbon stored in the ocean is far greater than that stored in the atmosphere or terrestrial ecosystems. This long-term storage highlights the ocean's importance in regulating Earth's climate over geological timescales. The ocean also influences Earth's climate through its interaction with the atmosphere. Evaporation from the ocean surface supplies water vapor to the atmosphere, driving cloud formation and precipitation. Ocean temperatures affect the intensity and frequency of weather events such as hurricanes, typhoons, and monsoons. Warmer ocean surfaces can provide more energy to storms, increasing their strength and potential impact. As global temperatures rise, understanding these ocean-atmosphere interactions becomes increasingly important for predicting future climate conditions. Geological processes within the ocean further shape Earth systems. Underwater volcanic activity contributes to the formation of new oceanic crust and releases minerals and gases into seawater. These processes influence the chemical composition of the ocean and, over long periods, affect global biogeochemical cycles. Submarine volcanoes and mid-ocean ridges also play a role in shaping seafloor topography, which in turn influences ocean circulation patterns. The movement of ocean currents affects not only climate but also the distribution of nutrients, organisms, and pollutants. Nutrient-rich currents support productive marine ecosystems, while changes in circulation can disrupt food webs and fisheries. At the same time, pollutants such as plastics and chemical contaminants are transported by currents across vast distances, spreading environmental impacts far from their original sources. This interconnectedness means that local actions can have global consequences within the ocean system. Sea level regulation is another crucial function of the ocean. As the climate warms, thermal expansion of seawater and the melting of land-based ice contribute to rising sea levels. The ocean acts as the final reservoir for this added water, affecting coastal communities, ecosystems, and infrastructure. Understanding how the ocean responds to warming is essential for developing strategies to adapt to sea level rise and reduce associated risks. In conclusion, the ocean is a central component of Earth's climate and environmental systems. Through heat storage, circulation, carbon absorption, and interaction with the atmosphere, it maintains the balance necessary for life on the planet. At the same time, changes in the ocean reflect broader changes in the Earth system, making it a key indicator of climate change. Protecting the ocean is therefore not only an environmental responsibility but also a critical step in safeguarding the planet's climate and future stability. Chapter 6. Current threats and challenges facing the ocean. Despite its vast size and resilience, the ocean is increasingly under threat from human activities. Over the past century, rapid industrialization, population growth, and technological development have placed unprecedented pressure on marine environments. Many of these threats are global in scale, complex in nature, and deeply interconnected. Understanding these challenges is essential for recognizing the urgency of ocean protection and for developing effective solutions. One of the most serious threats to the ocean is ocean acidification. As the ocean absorbs large amounts of carbon dioxide from the atmosphere, chemical reactions occur that lower the pH of seawater. Since the beginning of the industrial era, the average acidity of the ocean has increased significantly. This change may appear small, but even slight shifts in pH can have major biological consequences. Many marine organisms, such as corals, shellfish, and certain plankton species, rely on calcium carbonate to build shells and skeletons. Increased acidity reduces the availability of carbonate ions, making it more difficult for these organisms to survive and grow. Coral reefs are particularly vulnerable to acidification and warming waters. When ocean temperatures rise, corals experience stress that can lead to coral bleaching, a process in which corals expel the symbiotic algae that provide them with energy. Repeated bleaching events weaken reefs and increase the risk of widespread coral mortality. The loss of coral reefs has serious consequences, not only for marine biodiversity but also for coastal communities that depend on reefs for food, tourism, and protection from storms. Plastic pollution represents another major challenge facing the ocean. Each year, millions of tons of plastic waste enter marine environments from land-based sources such as rivers, coastal cities, and industrial activities. Over time, larger plastic items break down into smaller fragments known as microplastics. These particles are now found throughout the ocean, from surface waters to the deepest trenches. Microplastics are easily ingested by marine organisms, entering the food chain and potentially affecting animals at all trophic levels. The presence of microplastics in marine ecosystems raises serious concerns for both environmental and human health. Marine animals may mistake plastic particles for food, leading to physical harm, reduced feeding, and exposure to toxic chemicals. As microplastics move through the food web, they can eventually reach humans through seafood consumption. Although research in this area is still developing, early studies suggest potential risks associated with long-term exposure to microplastics and associated pollutants. Overfishing is another significant threat that disrupts marine ecosystems. Advances in fishing technology have greatly increased the efficiency of fishing fleets, allowing them to harvest large quantities of fish in a short period of time. In many regions, fish populations are being exploited faster than they can reproduce. This imbalance leads to declining fish stocks, altered food webs, and reduced ecosystem resilience. Overfishing can also have cascading effects, as the removal of key species disrupts predator-prey relationships and ecosystem stability. Habitat destruction further intensifies these challenges. Coastal development, bottom trawling, and resource extraction activities damage critical habitats such as mangroves, seagrass beds, and coral reefs. These habitats serve as nurseries for many marine species, support biodiversity, and provide natural protection against coastal erosion. Their degradation reduces the ocean's ability to recover from other stresses, including climate change. Climate change acts as a multiplying force, intensifying many existing threats. Rising ocean temperatures, changing circulation patterns, and decreasing oxygen levels all place additional stress on marine life. In some regions, warmer waters are causing species to shift their geographic ranges, disrupting established ecosystems and fisheries. Ocean deoxygenation, often referred to as dead zones, reduces the availability of oxygen needed for most marine organisms to survive, further threatening biodiversity. Pollution from agricultural runoff and industrial waste also contributes to ocean degradation. Excess nutrients, such as nitrogen and phosphorus, can lead to harmful algal blooms. These blooms reduce water quality, block sunlight, and, when they decompose, consume oxygen, creating hypoxic conditions that are deadly to marine life. Such events highlight the close connection between land-based activities and ocean health. In conclusion, the ocean faces a wide range of serious and interconnected threats, many of which are driven by human behavior. Ocean acidification, plastic pollution, overfishing, habitat destruction, and climate change together place immense pressure on marine ecosystems. While the challenges are significant, they are not insurmountable. By increasing awareness, supporting scientific research, and promoting sustainable practices, humanity can reduce its impact on the ocean. Protecting the ocean is not only an environmental necessity but also a responsibility to future generations who depend on healthy oceans for food, climate stability, and life itself. Conclusion. Protecting the ocean. Protecting our future. The ocean is far more than a vast body of water covering most of the Earth's surface. It is a complex, dynamic, and essential system that supports life, regulates climate, and connects all parts of the planet. Throughout this presentation, we have explored the immense scale of the ocean, its hidden structures, its extraordinary life forms, its unique ecosystems, and its vital role in maintaining Earth's environmental balance. Together, these elements reveal a simple but powerful truth. The health of the ocean is inseparable from the health of the planet and humanity itself. One of the most striking realizations is how little of the ocean we truly understand. Despite covering more than 70% of the Earth's surface, over 80% of the ocean remains unexplored. Beneath the waves lie mountain ranges longer than any on land, trenches deeper than the tallest peaks, and ecosystems that function without sunlight. Each new discovery challenges existing scientific assumptions and expands our understanding of what life can be. This vast unknown is both humbling and inspiring, reminding us that exploration and learning are far from complete. The biological diversity of the ocean further emphasizes its importance. Marine organisms display extraordinary abilities: regeneration, bioluminescence, complex communication, and extreme adaptability that have no equal on land. These adaptations are not only fascinating but also valuable to science, medicine, and technology. The ocean serves as a living laboratory, offering insights that can improve human health, advance scientific innovation, and deepen our understanding of life itself. Equally important is the ocean's role in sustaining Earth's climate and environmental systems. By absorbing heat and carbon dioxide, regulating global temperatures, and driving ocean currents, the ocean acts as a stabilizing force for the planet. It produces more than half of the Earth's oxygen through microscopic phytoplankton and stores vast amounts of carbon in its depths. Without these processes, Earth's climate would be far more extreme and unpredictable, making life as we know it impossible. However, this essential system is under increasing threat. Ocean acidification, plastic pollution, overfishing, habitat destruction, and climate change are placing unprecedented pressure on marine environments. These challenges are not isolated problems. They are interconnected and global in scale. Damage to coral reefs affects fisheries and coastal protection. Plastic pollution moves through food chains and reaches human populations. Climate change intensifies ocean warming, acidification, and deoxygenation, weakening ecosystems already under stress. What makes these threats particularly concerning is that they are largely driven by human activity. At the same time, this reality also offers hope. Because human actions contribute to the problem, human actions can also be part of the solution. Scientific research, international cooperation, sustainable resource management, and informed individual choices all play a role in protecting the ocean. Small actions, such as reducing plastic use, supporting sustainable seafood, and lowering carbon emissions, can collectively make a significant difference. Education and awareness are especially powerful tools. When people understand how deeply their lives are connected to the ocean, they are more likely to care about its protection. The ocean influences the air we breathe, the food we eat, the climate we experience, and the economic systems that support millions of people worldwide. Protecting the ocean is not an abstract environmental goal. It is a practical necessity for human survival and well-being. Looking forward, the future of the ocean depends on the choices made today. Advances in technology offer new opportunities for exploration, monitoring, and conservation. Marine protected areas, improved fishing regulations, and global climate agreements demonstrate that positive change is possible when science and policy work together. However, continued effort and commitment are required to ensure these measures are effective and long-lasting. In conclusion, The ocean is a system of extraordinary complexity, beauty, and importance. It holds countless mysteries yet to be discovered and plays a fundamental role in sustaining life on Earth. Protecting the ocean means protecting climate stability, biodiversity, and the future of human societies. By increasing awareness, supporting conservation efforts, and taking responsible action, we can help ensure that the ocean remains a source of life, wonder, and resilience for generations to come. In conclusion, the ocean is far more than a vast expanse of water. It is a complex, living system that supports life on Earth in countless ways. Throughout this presentation, we have seen how the ocean's immense size, unique structures, extraordinary organisms, and productive ecosystems all contribute to maintaining global balance. We have also learned how deeply the ocean is connected to Earth's climate and how human activities are placing increasing pressure on this vital system. Despite its size and strength, the ocean is vulnerable. Ocean acidification, pollution, overfishing, and climate change threaten marine life and the services the ocean provides. However, understanding these challenges also gives us the power to respond. Through scientific research, sustainable practices, and responsible individual choices, we can reduce our impact and protect the ocean for future generations. Ultimately, protecting the ocean means protecting our climate, our biodiversity, and our own future. By increasing awareness and taking action, we can ensure that the ocean continues to sustain life on Earth and remain a source of wonder, stability, and resilience for generations to come. Thank you for listening.